This one is a stoichiometry prac. What we're actually doing is making copper metal from a solution of copper sulfate hexahydrate. And what we're actually going to do is use aluminium to displace the copper out of solution so that we end up with copper metal. So like all stoichiometry, we need to be very precise about particular things. And this is one of the things that as a chemistry teacher, you can help your students with is what thing needs to be precise and what thing doesn't. So if you really understand what's going on and why you're doing what you're doing, you can be a lot quicker. When I was studying chemistry at uni, I was usually finished my labs half an hour to an hour before most of the rest of the class because I knew which bits I had to be precise and slow about and which bits I could be rough and quick about. So understanding what's going on can really help in chemistry. So what we're doing, we're going to first make our copper sulfate solution. So I'm going to take the mass of my beaker. Let me tear the balance first so that it's at 0, and then measure my 100 ml beaker, 58.17 gram. Now I want to measure into this 2 grams of copper sulfate, and I need to know exactly how much I've got. It's the point I made in another video about precision versus about. So we want very close to 60 grams in total, and we want to know exactly to 2 decimal places what we've got. Normally in a chemistry lab for stoichiometry, we would do 3 decimal places. We would have a more precise balance than this one. But for our purposes, this will work. So that's 59.6, just kind of a couple of grains at a time. 60.06 will do nicely. So it's not exactly 2 grams, but we know exactly how much it is. And now it's gone up to 60.13 once it's equilibrated a little bit. So I'm going to write that one down too. Now we're going to make a solution of the copper sulfate. So what we will do is we don't particularly care about how much water we have because it's not participating in the reaction. It's just a medium for the reaction to take place in. So if we cared about the volume of the water, we'd use a volumetric flask, but we don't. So we're going to use a measuring cylinder. So a measuring cylinder is a lower level of precision. This deionized water bottle is not cooperating very well. It's just going to make me work for it. There must be a leak. Now I'm getting down so that I'm at eye level with the meniscus. So, you know, by not being very precise, I don't mean that we get 20 mil instead of 10. But if we get 10.2 instead of 10.0, it's not a huge issue. So I've got my 10 milliliters of water. I'm going to add that to the copper sulfate and stir it to dissolve. So you should see that as those crystals dissolve, we go from blue crystals in water to a blue solution. And the goal is to get that dissolved. Taking a moment because they were large crystals. But we want that to be a solution, not any kind of suspension. We could have made that go quicker with hot water, but we didn't have prepared hot deionized water. We want to make sure that it's dissolved so that it can participate in the reaction, because if it's still there in solid form, it will participate in the reaction as the equilibrium shifts, but it will take a bit longer to happen. So we'll take the extra time to dissolve the substance to make sure that it's ready. Now to that, we're going to add 2 ml of 6 molar hydrochloric acid. 6 molar hydrochloric acid is quite nasty. Under normal circumstances, we'd do this in a fume hood. I am wearing my safety glasses and lab coat, and I'm going to do this with great care. We are shooting outside the fume hood for video purposes, but we need exactly 2 mil of this one. This one really isn't participating in the reaction either. We're basically doing a reaction between aluminium and copper. And both the water and the hydrochloric acid are kind of facilitators that make that happen rather than participants in the reaction. So I'll add my 2 mil of hydrochloric acid. I don't know whether you noticed there was a very slight change from blue toward green as that went in. It's gone back to a blue solution now. So we've got our solution. Now is the key bit. We need to weigh out the aluminium. Now the aluminium is the thing that we need to know very precisely, because basically we're going to take the aluminium and conduct a reaction that means the aluminium goes into solution and the copper comes out, and then we're going to measure the amount of copper that we get as a result. So the aluminium is kind of the key thing. I prepared one earlier, so what I hope is that, in fact what I know, because I measured it carefully earlier, but I can't measure it now because it's in the beaker already, is that this is exactly 0.25 gram. And again, if I had a better balance, it would be 0.250 gram, or it would be 0.252, but I would know that it was 0.252. So I'm going to add my 0.25 gram of aluminium foil. It's just very finely chopped up household aluminium foil to that solution and stir it with the stirring rod. And it will start to react. Watch the color of the solution and watch for fizzing. There's just starting to be some fizzing. There's a little bit of oxygen on the outside of that aluminium, so it takes a moment before it really gets going. But I hope you can see that it is now fizzing. There's some fuming coming off because it's a quite strongly exothermic reaction. It's bubbling quite a lot, and the solution has changed from that blue color. It looks kind of grayish at the moment because there's just a lot of aluminium there. But we'll react it as much as we can with that much acid. If we were to put a flame in this, it would go pop because it's hydrogen gas coming off. I'm just going to leave that for a moment. The next step that we're going to do, and I'll get ready for it, is we're going to add an extra 5 mil of hydrochloric because we want to make absolutely sure that all of the aluminium's gone. The goal is to make sure that we've got no aluminium left and all copper deposited on the bottom. I don't know if you can see, but some of the aluminium pieces now have a coppery coating on them. Let's just make sure that that has fully reacted because it's still fizzing a bit. We will add that extra 5 mil. Getting down to that meniscus again. You can see the reaction slowed down, but because it is a stoichiometry experiment that we're doing, we want it to be absolutely completely reacted. We don't want any trace of aluminium left behind in the system. You can see there is still some fizzing. There are still some silver bits of metal in there, but there's also a lot of brown chunky ones because what's happened is the copper metal has deposited out, but in very small flakes. So it's not the normal pinky golden color of copper. It's a brown color. So I think at that point the reaction's gone to completion, and you can see that it's no longer at all blue. in colouring. The copper sulfate that was in solution, or the copper that was in solution, copper ions, which are blue, are all gone. We've got solid copper metal instead. So the next step is that we're going to decant it into the sink. So we're going to pour off all of this, into a waste beaker, because we don't want to pour any remaining concentrated hydrochloric down the sink, nor do we want to pour aluminium salts down the sink. So we will decant it into our waste beaker. So all we're trying to do is pour off as much of the liquid as we can without pouring off any of the solid, because the solid's what we're going to weigh and measure, and it's the result of our experiment. So the last thing we want to do is lose any of the solid. But if you're used to pouring Cooper's Pale Ale off the yeast, you'll be good at decanting this. And then, just to make it easier to find out our result quickly, what we're going to do is quickly wash it with some methanol. Methanol is just an alcohol, not the kind that's in Cooper's Pale Ale. You're going to just wash it with some methanol, because that will dissolve the water, or dissolve in the water, whichever way you like to think about it. But it is much more volatile, so it will dry much more quickly than it would if we just left our copper wet. So I will give that a swirl. And then we can also decant off the excess methanol. So we get it as dry as we can by decanting, and then we're going to cook it down on a hot plate and determine the mass of the remaining copper. I don't know if you can see that. You can see the brown copper metal in small pieces that we've actually got from this result, and we'll let you know what the actual result is. So we've essentially reacted 0.25 grams of aluminium, and our result is X grams, TBA, of copper, and we want to know what the actual yield of that reaction was. Was it 100%? Was it as efficient as the chemistry reaction equation would tell us? Or was it slightly less efficient because of any errors that we made or any other issues? That's the goal of our stoichiometry experiment.